Hi, it's Gadget UK here again. This time we're looking at a Commodore A590. So these are very rare and very expensive generally. Now I managed to get this one for around £50, but it's not got the case. You know, there would be a big, quite a deep case that goes with this. It accommodates the hard disk and stuff inside here as well. And I've given it away there. That it is a hard disk and RAM board. This, you can see the Scuzzy Connector back here. It's marked on the silk screen there, Scuzzy drive CN6, so that's where your 50-pin Scuzzy IDC connector would go. And you've also got a connection here for XT drive, which was the 8-bit IDE precursor. You know, it came before 16-bit IDE, standard IDE as we know it. It was like an 8-bit version. The interesting thing is there's like a connector there for XT as well. I'm not sure what that's all about actually. So you've got a 3-pin connector here where your power connector would go to your drive. There would be a little fly-off that's got like a normal Molex connector, I presume. Now if you've seen my recent video on the Commodore A2091, that's very similar to this, almost identical in fact. A Scuzzy controller for the Amiga 2000 there, you know, it's got the Zorro 2 interface. And this mates with the side of the A500. That's something I've not pointed out here. It's the sidecar that goes on the side of an A500. I'm sure it would work on a 500 plus as well. So just like the A2091, you can see we've got space for 16 chips here, which would give you 2 meg in total. On this one, and I'm not sure I noticed this on the 2091, but the marked here, 512K, 1 meg, I presume that's 1.5 meg, 2 meg. I'm not sure if you can go to 1.5 meg actually. Yeah, and you can see the jumpers here, 512, 1 meg, 2 meg, and the top one says Amnesia. I've stuck a jumper on there, there was no jumper, that's the first thing. Why someone would take the jumper off it, I don't know. It might be a bit like the A2091 where if you've got no jumper on there, it just goes into the amnesia mode anyway. You know, the no RAM, no additional RAM. It's got the Dmac chip here, it's the Rev 01, this one. In theory, I think we could probably just swap this out and borrow the one from the A2091 to test this. Correction to the A2091 video actually, I mentioned that the A3000's got a Dmac chip, and that's true, and the A3000T, but it's a different Dmac chip, it's the Super Dmac. I think it supports the Zorro 3 address range. This is a Zorro 2 device. So my first thoughts before bidding on this were probably these 245s here may be faulty, or the ROMs, maybe the Dmac. Very worst case, one of the PLDs. We've got one here, although that one's got a Commodore part number on it. I think it is actually a programmable part that you can fit there, and one here. Now one of them is for the BG, is it the BG line? Yeah, I think it is the BG signal, and it's kind of optional. There's a jumper somewhere, depending on whether it's set or not, determines whether you want to use that chip. I'm not sure why there was an option there. I'm just going off the schematics here, by the way, when I'm talking about that. One of them generates the CAS and RAS timings for the RAM here, but the JEDEC is available for that particular chip. I've got that. It was on Dave Haney's website in years gone. I found a mirror of his site recently, and that's where I got the JEDEC from. So if that's faulty, we can swap it. Yeah, you can buy them. I could buy a Rev 2 and fit that. RAM, I've got plenty of spare RAM. But my guess is these. Anyway, we're going to plug it in and see how it's behaving. And it just basically plugs onto the side there like that. That's it. So support off the floor. So I'll connect up the power and let's see what's happening. So I can't really see the colour, it's green, isn't it? Green screen. That means a RAM fault. So let's just disconnect the power again and plug it back in. And the thing is, when it gives you green for a RAM fault there, that's chip RAM, but yellow there means an unhandled exception has occurred early in the boot process. So the CD32 power supply does indeed output 5 volts on that top pin there on that side. Let's just check the ground. The bottom two should be grounds. Let's just test from there. Yeah, that one's a short. That one isn't quite a short. And I'm guessing this side here is going to be one of the 12 volt connections. Yeah, that's the 12 volts. So I think we're okay with that CD32 power supply. So with it powered, let's see what's happening now. Now we're getting a white screen. Is it just going to hang there, or is it going to come up with a kickstart eventually? Yeah, it has done. So, actually, there may be nothing wrong with this. There may be nothing wrong with this at all. Maybe someone's done the mistake I have there, just to connect it all up without a power supply and assume it should work. You know, in theory, you could probably join up the 5-volt rails between this side and that side. It's probably output on here somewhere. It's just whether it's actually used to supply things on here. And it may well be that a fault has developed on here that means that it's only capable of drawing power from the power connector there. Actually, thinking about it, because you'd have an issue that if the 5 volts wasn't powered by this side, you know, the Amiga side, you could have a latch up type sort of thing going on where, you know, the order that you power things on. And I'll be honest, I had a little bit of concern of that when I tried this a minute ago. I was thinking, do I switch this side on first or that side? So I tried to do them almost at the same time. Anyway, I'm going to go connect a Scuzzy drive up. I've got a Scuzzy 2 SD. We'll plug it in. I'll experiment with the jumper, dip switch 1, and just see whether it's booted. So I've got a drive connected up there. I think there is some activity if you just leave it long enough. Hang on a minute, we've got a RAM issue because we've got stuck on the grey screen there. I re-enabled the 512K. Yeah, it's a RAM issue. So let's swap out those 4 RAM chips, I think. So I didn't show you, but through process of elimination I've worked out that the issue was the chip in this position up here. In theory, what we could have done is booted sys-test, you know, sysdiag or whatever it's called, or some other RAM test utility, and tested the RAM and worked out which bits were the issue, and you know, tackled it that way. But there's only 4 chips, so it was easy to. You can see this one down here. This is a brand new one, so I fit a brand new one there, tested it just the same. So I took the chip that I'd previously had in there, put that in there, and removed that one, tested it. Did the same until we got to the end, and it was this one here. As soon as we swapped that chip out, that's when it sprung back to life. As you can see there, we've no longer got a grey screen. So I think that should mean that we've got 512K of additional RAM now. So I'll try booting from the Scuzzy again. I didn't show you, but what was happening, it was starting to boot, and then it was saying it's gone up with out of memory, not validating the disk because it didn't have enough RAM, you know, not enough memory. So let's give it another try. So just trying that again. It passed the memory test there, look, hard disk access. Now it was doing this before, and then it was running out of RAM. Let's see what happens now. It's doing the same thing. Yeah, so we've hit the same issue there. I'm wondering if it just needs some more RAM, actually. What I might just try and do is boot from floppy disk and just do a memory test. Let's do that, just to rule out the RAM that's on that board. So I was having problems booting syscheck there. I tried various things, nothing's booting from floppy, so I thought there was a problem with the floppy drive. So anyway, I changed dip switch 1 over to the off position, and it's booted from floppy. Tune's working fine. That needs 1 meg, so that's kind of showing me the RAM's alright. Let's now try it again with syscheck. It's interesting that I had to disable the boot facility of the Scuzzy drive, because whilst it was actually looking at the drive, it was then, after it read the boot sector, it didn't actually boot from it. It then went over to the Scuzzy. So maybe that's just because I'm not familiar. No, it's not booting again. So maybe my syscheck's got corrupted. Oh, that's a pain. That's worked now. Look. Yeah, I think that syscheck disk needs rewriting. Let me just plug the mouse into the correct port here. So if I go into memory, oh there you go, got 1 meg of total. Half meg chip, half meg fast. So it's proper, true fast RAM on this. So let's just do test all memory. Yeah, so you can see that's going through fine, no problems at all. I think we've turned a corner. The RAM was the issue, probably the only issue with this board. So I think I'll fill the remaining chips. We'll take it right up to 2 meg and then see if it'll boot. So I added an extra half a meg, and I'll admit that was a little bit troublesome. I had yellow screens and things coming back and failed boots. It was just like hanging on the white screen. It wasn't booting from the floppy. So I unplugged it, unplugged the board, plugged it back in, retried it, worked first time. Prior to that, I tried a number of things, including disabling the RAM again, removing the chips. I was going around in circles with it. So the Zorro connector there is dirty. It's going to have a dirty connection on the side. That needs cleaning up as well. But it seems to be working. So I fitted the full complement of 2 megabytes here, and I think hopefully it should boot. Now, the one thing that did cross my mind while I was plugging those in is, well, I need to get Kickstart 3.1 in here, because the hard disk image came from 3.1. LEDs flashing, flashy again, flashy look. As you can see, it needs version 2 or greater. Well, let me just go see if I've got one of those ROM switches in a socket. And yes, I do, thank goodness for that. The one I'm going to show you, there'll be a separate video on this. This is the one from Boobib. There is a similar product from Solid Core, which I've shown in my channel before. I'll stick a link up there to that. But the one from Boobib provides a little bit more functionality, actually. Got to get one of those dip extractors, I think, that Adrian Black covered. Where's pin 1? It's not obvious looking at this where pin 1 is, actually. I think pin 1's at the top here. Yeah, and it's already in a socket so that you don't damage the actual socket. We'll just leave the reset wire floating just for now. Hopefully it's still on the Kickstart 3. We'll soon find out. And with the Kickstart 3.1 ROM, as you can see, it's booted up. There are a few issues here. Can you see DH2 non-DOS, DH4 non-DOS, and DH1 is not showing hardly anything on it. Let me just do view all files. Yeah, so DH1's okay, but we're missing DH2. It's not showing DH3 and DH4. I think the issue with the other two drives is the size of the partitions and the version of ROMs that are on this A590 here. So as you can see, I borrowed the ROMs here from Booty McBootson that we covered in a previous video. And it's working. And now let me just go to Kickstart 3.1. Oh yes, and you notice here, all the drives are there. So that just goes to show that you do need the version 7 ROMs for larger size disks or partitions. So that was the issue, that's why these drives weren't showing up. So if we click somewhere now, we should see, yeah, we've got 2 meg of fast RAM there. Mouse is not very good here on this thing I'm using. We've only got half a mega chip. Let's try loading something from DH2. There should be some games on here. You need 1 meg, oh great. It seems like everything needs 1 meg. It's ages since I've played with a 500 like this with no additional RAM. I mean, alright, it's got additional RAM, but it's not chip RAM. I'll stick 512K of expansion RAM into the expansion slot and we'll retry it. If you look at the total here, the maximum column, we've got 3 meg. So it's merging the slow mem with the fast memory there. It'll show up differently for boot sysdiag. But anyway, the main thing is it's booting and all the drive icons are there. Oh yes. Now it flickered a bit when it was loading in, which is an indication there's still not enough RAM. It's probably the chip RAM it's struggling with anyway. Let's sit fire. Sweet. Oh yes. Scuzzy on the A500, fantastic. Why is my controller jumping up and down on its own? But we've got a CIA problem on this actually. Yeah, I need to test out the CIAs on here because this one's bouncing up and down on its own, look. So there's an interesting issue here related to the Rev 6. I'll show you Rev 6A. And I've seen this before on 6A boards, and it can drive you nuts. You know, you get this where you don't power cycle it properly and stuff. And I think ultimately the address lines or data lines need some resistor packs on there, I forget which. It's one of the boards where Commodore for whatever reason omitted them. And it can cause you some interesting issues. Certainly with the A590, I'm having a really difficult time getting this to boot. I'll try power cycling it again. So the next thing I'm going to do is update these ROMs to version 7. So we just need to carefully, and I don't like putting pressure on that chip there, just try and lever this out here. They are pretty stiff in these sockets. Yeah, there we go, it kind of went up on one corner, but the pins are nice and straight, so that one's that one. And I previously wrote on the underside, I don't know if you can see on the silk screen, that says U12, that one's U13. This one's got a red 13 written on the underside of it, just so that I didn't mix them up. So I've got the EEPROM programmer here. We're going to dump the number 12 first, this is the U12. and if we get it into the socket there with its pin 1 notch at the top here, close the ZIF socket there, it's nice and firm. So I will need to remove these labels. Now I'm not sure if I'm going to be able to save these. On the A2091 I was able to save them, you know, I was able to just peel. Luckily I've not cut my nails in a while, so I've got long enough nails to see if we can try and carefully peel these off. And then what I'll do is just stick them on the underside of the board to retain a bit of history. You can see it start to rip there, look, this is the problem. A bit of IPA might help, or you can maybe even heat it with a little bit of hot air if you want to try and save these. It's not that important, some people will just rip them off. I might end up just destroying these in the process here. So I'll just tape those on the underside of the original PCB so it's got the history there. But the main thing is you need to do that in order that you can erase this chip and have a look at which chip it is. So it's NM, whoever that is, I'm not sure of that manufacturer, 27C64. So in the EEPROM program software, if you type 27C64, we've got a few here. NM, that's the one, isn't it? Yeah, there it is, NM. So NM27C64, it's National is the manufacturer. And if we choose select, so then if I choose from the command menu read, look at the speed of that, that's crazy fast. So it's a bit over bright in here, it's difficult to get the screen at the right angle. So just looking on the right hand side here, you can see the ASCII representation of what has been dumped. Let me just scroll down. I'm not sure whether we're going to be able to read anything in there. Sometimes when you dump in a ROM, you may see some readable text. The fact there's two of these, I think it's slim chance we're going to be able to see anything in there, because it's going to be split between the two ROMs. So the next thing I'll do, and I've covered this in other videos before, despite the fact we've read it, let's just do a verify. That's just going to verify what we previously read against the actual contents of the chip. And you're not going to be able to see it, but it says data is verified. That means that what it's read back was the same as what it read the first time, and we'll do that a few times. And then I'll take the chip out, put the chip back in, and do the same thing. We're just verifying with a more certainty there that we have actually done a good read of it. Yeah, data is verified. So at this point now we'll do file save as, and that one was U12, so version 6.1 I think it is, -U12, and we'll click save. And we'll just do exactly the same process on the other chip. While that one's reading, I'll remove the label from the one we've just done. That just means I'll have a copy of the original 6.1 ROMs there, should I ever need them. So now we've read them both and removed the labels. Both of them came off without any tears or anything. Just clean up the windows here with some IPA and a cotton bud. It's important that you do that because any sticky residue there could mean that when we erase them in a minute with some ultraviolet light, the light may not shine through properly, and a specific part of the surface of the chip there does not get bombarded by the ultraviolet light, which means it won't erase properly. So we've got our cheap EEPROM eraser there, chips facing upwards, sort of in the centre. Slide the drawer closed, switch it on, and set the timer to about there. That's probably about 15 minutes-ish. And you might just be able to see a little bit of purple tint there. Can you see that? That's the UV light inside. So it finished erasing those chips, and I left it for a good 5 to 10 minutes. That's it might sound like a pointless thing. You may think you could just take them out, blank check them, and they will come back saying the blank, and then you can program them. I have found myself that if you don't leave them 5 to 10 minutes after the UV light has been erasing them, weird things can happen. Like it shows as a blank, and then you come to program it, and you get to a certain point, and it fails to write. And then you've got to erase them again, and you can go round and round and round in circles if you're not careful. So yeah, the experience I've had is leave these for 5 to 10 minutes after the UV. So we'll do U12 first, so we'll get that in there. I've got the ROM files that I'd previously downloaded from the net. So in the buffer here, we've still got the previous file we dumped, so what I want to do is do File, Open, and if I do Show All Files. So we've got the ones I dumped earlier, version 6.1, U12, U13, and there's the ones I downloaded from the net. So as I say, we're going to do U12 first thing. Let me just check. Yeah, the other one's U13 that I've got here. So we'll open that, and you just choose OK. So there's our ROM, and we just go to Command, I'm not even going to do a blank check because it should be blank. We'll just choose right. And then wait for that to complete. Wow, that was fast. It's because it's such a small chip. Probably like 8K each or something like that. There we go. That's one done. And again, command right. Hopefully it'll work. Sweet. Device verified. And as I say, the ROMs we're using here, the version 7, they're identical to the A2090 one. It's the same ROMs between the the two different boards there. This is effectively an A2091 for an A500. Oh yes, that's worked. So the main thing is you can see these drives that were shown up as non-DOS drives before. So that has sorted it. It's now on version 7. So yeah, what I said in the A2091 video about needing version 7 for larger partition sizes and things, that's absolutely spot on, and larger drives, because those drives were just showing up as non-DOS with 6.1 ROMs. And if you need to print your own labels for things, just get one of these Dymo letter tag things, like a label printer here. And you can print them out in either matte or gloss finish, and you can different types, different colours. You can get like red, green, blue. You can get ones with silver on there, etc. And then you just fold it, and you can peel the backing off here. Look, it's already sticky, which is really nice. It makes things like this a breeze. There we go. So I think most people would have just put those labels in the bin, but I like to just try and keep the history that I can with the board. So games like this really take advantage of hard disk, but everything within WHD load will, benefit from having a hard disk here. You can't load games from WHD load without a hard disk. Fantastic. I think you really need more than half a mega chip RAM though, because I have seen this kind of. What happens with WHD load when you've not got enough RAM? Occasionally the screen will go black, it'll pause for a minute, and then it resumes, and it's like it's loading things in and out of RAM. It's having to page in and out there in the limited space it has. So I would recommend, if you're going to do this to an A500, get a Scuzzy board like this. Make sure you've got at least 1 meg of chip. Tested a bit of time gal straight from the hard disk here. It's streaming fine. I don't see any slowdowns or hear any slowdowns. One thing I will say, it does need 1 meg of chip. I tested this before and it wouldn't launch. It doesn't do anything when you double click the icon. Sweet. Right, I think we'll do a benchmark on this. I'm just curious to see how fast this drive, the Scuzzy 2SD, is running here. I'm guessing it's going to be the same sort of 1.1 meg or 1 meg-ish that we saw on the A2091. So if we go into memory here, let's just have a look at that. So we've got 2 meg fast kick, 24-bit DMA. So that's the memory provided by the A590, and 1 meg chip exit. And if we look at drives, we'll just do DH0. Yeah, it's just under a meg there, so it's a bit slower than on the A2000 when I was testing the 2091. Well, that was a shock. I suddenly could smell something getting hot. These 3 chips here are ludicrously hot. I hope it's not killed the Dmac. Ow. Yeah, all 4 of those there are incredibly hot. Something bad has just happened to this. So this is very interesting. Yeah, I burnt myself. I've had to put some stuff on my finger there. It's stinging like mad. It's the hottest temperature I've felt in ages. It was hotter than a soldering iron. Seriously. So I swapped a chip. So we've now had 2, and it's one of the original ones. Yeah, so you may think, okay, it's these chips, it's these original chips that are the issue. I don't think it is. Something is killing them. So, they're nice and cool now. Everything's fine. It's booted to the desktop. I'll show you that in a second. So what's really weird about this is when I connect this floppy drive up here, and I've double, treble, quadruple checked the connections for the data and the power, everything's the right way around. But when I connect this up, these 4 chips here start to get ludicrously hot very quickly. The system stops and these get so hot you can't even touch them. You've got to switch it off within about 5 seconds. They're almost as hot as they were when I burnt myself on them before. So that is really, really weird. How can connecting a floppy drive up cause these chips here to short, something shorting completely on them, because they're red hot, absolutely red hot. I am not understanding this in the least. The drive is connected up the same way it's been connected up all the other times. And as you can see, it booted as normal, the system's running fine, everything is behaving normally. So I don't understand how connecting a floppy drive up could be setting those chips alight basically on that board. That is just ridiculously crazy. So I spent a fair bit of time thinking about the problem, feeling around the board, measuring things, measuring voltages. I even considered, was it the mod I did to the memory expansion that's in this? You know, maybe something was backfeeding 12 volts into 5 volt rail. That isn't the case at all. I can find no clues. But then I remembered, just before this happening, one of the things I noticed, I was playing a few games on this Rev 6 board before I had the floppy drive connected, when everything was working. And I noticed it seemed like the filter was on all the time. I mean, it could have been off. So I thought, well, we'll boot sys test. So this is exactly why I was connecting the floppy drive up. So I'll show you, switch these channels on and off. That's working. Switch it on, and if we go to filter, it's not making a difference. Let's just put on 10 kilohertz. I'm going to turn that volume up. I'm not sure I can hear it. The filter's on all the time, isn't it? The filter is on all the time. If I turn the volume up, right, it's on very high now. Hang on. Yeah, the filter's on all the time. So, has that got something to do with this issue? I mean, it's a crazy fault if it is, but I don't know, let's say there's a chip or transistor there shorting something somewhere. Maybe that's the issue. We repaired this Rev 6 board in a previous video. I couldn't find much wrong with it really, apart from dirty sockets and stuff and the odd bit of corrosion. But it's always been on my mind that there could have been something more wrong with this, and I think this highlights it. So hopefully you can see everything here. Got a ground down here, got it on volts DC, and if I measure pin 2, right, that's pin 2, that's the underscore LED signal. And if I switch the filter on and off, hang on. Oh, hang on a minute, it's crashed now. Hang on a minute, it's not power cycling now. Because I was measuring voltages on this, I'm just going to redo that now. And then suddenly the system went off, it hung, it froze, couldn't reboot it. And again, feeling around on the tops of things, this CIA here was red hot. So I don't know what's going on here. I think maybe this CIA is the issue. If this CIA controls the audio filter, that might explain it. But it could be there's something wrong with the filter that's killing the CIA in that position. So anyway, I'll report back in a minute. You can see I've got two CIAs back in here now, and it's working. Now I've not tested the one that was getting hot here. We may still have an issue with that. It could have killed it. I don't want to leave it powered on too long while I start doing measurements and showing you. But on pin 2, we got 5 volts coming into this here, the underscore LED signal. And on pin 3, it's like 12 volts. And as I toggled that LED signal there, switching the audio filter on and off, the input toggles between 0 volts and 5 volts. So that's, you know, the input going into this is working. So from a software perspective, actually setting that, you know, the signal that goes in there is correct. But I still see 12 volts on pin 3 all the time. I also measured around the transistor here as well that's responsible, and the 2 resistors there and the one over here for like the bias and all that sort of stuff, and everything around there seems fine, including that transistor. So we're all back up and running, everything is fine. Temperature wise, no issues, nothing getting hot. I did spend some time looking at the schematics, because you can see for the moment we're missing 1488. So without that 1488 and having swapped the CIA here that burned up, everything seems okay. And as I say, I spent some time looking at the schematics. Now remember, when the drive was the issue, this CIA was here, which is predominantly used for controlling some of the signals like motor on and stuff here to the floppy drive. That was when those chips on the A590 over here were going incredibly hot, and it's no coincidence that when I swapped the CIAs around here, a few minutes later this one burned up. So this is the one that was there related to the 1488. That's the thing I forgot to mention. Some of the signals that come from here, they're going through the 1488 here to the floppy drive. and sorry, not the floppy drive. Some of the signals come here, and I think the serial port has come from here as well, but through this chip. So it's a consequence of swapping these round. It died when we moved it to here completely. Wasn't working when it was here with this connected. The interesting thing is that was working floppy drive when the 590 was not connected. So it's a little bit odd, but nevertheless everything seems alright. The 590 is alright. The RAM's all testing out good. So in that catastrophe there, we worked out the 1488 as the issue, I think. We killed that, tested that, that is completely dead, and we lost another one of the original RAM chips that were on the 590. So, very interesting. Anyway, I need to wait for a 1488 before I'm 100% convinced. And obviously, I think the audio filtering goes through this, so that's not going to work just at the moment. So I believe I have finally got to the bottom of it. This has been a real trauma. I say that a lot, this has been a nightmare, but this really has been a nightmare. What I have come to the conclusion with is these serial transmitter receiver pair down here are a real significant risk to damage occurring on one of these boards. If you're getting the behaviour with the 500 that I've seen here, where CIAs are popping for fun, just swap those two out. Don't even mess around trying to measure them, because I measured pin 3 and I was very careful. Let's move that cap out of the way a little bit. I was very careful not to short the pins, because if you do short the pins, you're going to have a problem. Now, pin 3 was measuring 12 volts, which I thought was strange, actually. But at that point, the screen went straight off, and I thought, what's going on here? And I put my hand on here, that was red hot, and these chips over here were red hot again. So I switched everything off super quick. We swapped the CIA, and I thought, okay, well, maybe the CIA caused it. So, what did I do? Actually, I swapped to this one. I think I had this one in that position. At that point, I was just booting with one CIA. And powered it on. Everything was fine. Measured the voltage. I didn't have the floppy drive connected at this point. Measured pin 3 again there on the volts. Bang! Straight away, power went off. The screen went off. And I thought, it's done it again. Switched everything off super quick. This was boiling hot. It killed a second CIA. So, yeah, I was gutted yesterday. I had a very expensive car repair to my wife's car as well, and I went through £40 worth of CIAs, because to try and buy these for less than £20 each now, there was a time where you could get these for about £5 each or less, and I bought a number which has been enough to populate the boards you've seen on my channel. But I've got no spares at all, none, so I was 2 down, which meant one of my boards has got no CIAs on it, which is a bit of a pain for testing, because as you've seen in this video, I like to swap between the Rev 3 board, the Rev 5 board, the Rev 6 board, and my 500 plus of stuff, in order to test various things here. Anyway, I've ordered one of those, and I'm bidding on one at the moment. So what did I do? Well, after 2 of them dying, I dare not measure pin 3 on there again, for sure. And this is without the 590 connected and without the floppy drive connected, just by virtue of having the board as it is. It boots, it's fine, you do every test on it, fine. Tested the serial and parallel ports, everything was fine. Measure pin 3, pop, you pop a CIA. Yeah, that is just crazy, absolutely crazy. So I thought it's got to be something to do with the 12 volt rail, assuming that this was related to the issue with the A590 when the floppy drive's connected, because that was weird in its own right. Toasting the RAM chips over there on that top corner of the A590 when the floppy drive tries to boot was kind of a clue. So I was like, well, what's the floppy drive got to do? At that point I noticed the audio filter wasn't working, and then I started homing in on these. That's when I measured that pin, because I was trying to follow the filter the LED signal, and I thought, I wonder if that's something to do with it. I think it is. I think when we swap these with brand new chips, I think the audio filter is going to work properly, and I think all of our problems will be resolved. The second time the CIA went, I tested the serial port with a new CIA, and we've got a serial port issue as well. So whatever the fault was, blew one of those ICs anyway. But we still had the same issue. I removed the 1488, just tested the 1489, and strange things were going on again with the floppy drive when the A590 is connected up. So I thought, okay, it must be both chips. Previously, the pins had been pushed back on the serial port. I didn't mention that. At the end of the repair of the R6 here, I noticed that the 2 pins on this side here, which are probably for the supply rails here, minus 12, plus 12 probably, I think. I'm not sure they both go there, one of them does. They were pushed in slightly, so I pulled them back out. So I know that that's not the problem at the moment, but whatever fault has occurred with these chips here meant that the serial and parallel ports were working, but when the floppy drive was connected, and the A590, it was toasting the A590 RAM. And when we measured pin 3, it was killing, insta-killing, like within a split second. You know, I had the power ready on the second one, and as soon as it started to get warm, switched it off, it had already died. It'd gone straight away. And I can perhaps show you that. If we measure the pins, it's the actual pin I measured here, pin 3, on both occasions. On the second one, I think the one next to it had gone as well, shorter to ground, or shorter to VCC, I'm not sure which. So a very expensive lesson for me. I would say that in the 8 or so years my channel's been going, I have never had something where it's been popping an expensive component like that you know, makes it very difficult and scary to work on, really. I think the nearest example to something like that on my channel was the Neo Geo AES power supplies. One of those there was popping, destroying the triac and something else, so each time it blew, it was like 3 or 4 quid in the bin. But, you know, power supplies are one thing, but when you're dealing with, you know, custom chips on these, we don't want to destroy these. These are, you know, getting rarer in number, so I am gutted that it killed two CIAs. It's a you know, a hard lesson learnt, really. So as you can see all the time we've been talking there, it's been testing the RAM there. We've got 1 mega chip, 2 mega fast, and it's been going round with that issue. So I think the next thing I'll do is remove the floppy disk and actually boot from the hard disk. So a bit of Alien Breed Special Edition, that should now work. Now we've got 1 mega chip. The filter I think is going to be either off all the time or on all the time, because I think it's needed by the 1488. I could be wrong. Yeah, it sounds on to me, if I'm honest. But that might be normal on this game anyway. Yeah, it's definitely on. It's like really low, you know, the high frequencies are getting filtered out there. So that's been on test for about half an hour now. No problems at all. It's rock solid, and the floppy drive is not interfering with the RAM. You know, causing RAM to exceed normal voltage or temperature. I'm not sure what was going on there. I'll have a think about that and tell you what my theory is in a minute. Anyway, yeah, you shouldn't handle chips like this with your fingers. You need ESD protection, but these are, both of them, there's 2, I'll show you. These are completely balked, so you can rub it around on the carpet as much as you want. These are well and truly gone. So I'll show you on continuity here. The ground pin is pin 1 here, and the pin that blew as I measured on the pin 3 of the 1488, you'll see, is here. So that's one of the input pins. It's an I/O pin rather. You've got like an A bank and a B bank or something like that. It's a number of I/O pins, but it is a dead short, and the pin next to it shorted on this one. Oh no, it hasn't. That's the other one. So on this one, it was just that one pin. Yeah. On the other chip, this is the first one that blew. Exactly the same thing. The pin we were measuring is this one, just measuring on volts DC, and the meter was definitely you know, you can't get it the wrong way. It's not like I put it in current mode and shorted the pin out. I didn't, because you'd have to have the probe in a different connection on the meter. We literally just measured volts DC on this pin here equivalent, because that just goes straight to pin 3 of the 1488, and it's just from measuring that there, bang, it went instantly, destroyed it. But on this one, the one next to it is dead as well. And I think the reason the one next to it's dead, it was probably still able to process. It was like the system was doing something, this pin shorted, it transitioned to this pin shorted, the system went. Does that make sense? So it's not uncommon if you do get a short from some sort of thing like that, that you may find 1 or more pins shorted out on it, as it's tried to continue processing while the short has been, you know, gradually pulling the voltage level down to the point where it can't do anything anymore. Anyway, that's yeah, it's gutted me a little bit, the fact that these are in the bin. I don't think I've had a faulty CIA chip in quite a while, actually. You know, in any of the things I've repaired, it's quite uncommon. It's common for them to fail, but out of all the things I've picked up in the last 8 years, I think maybe I've only had 1 faulty CIA chip. And I think that was on one of those Rev 3 boards I showed on my channel earlier. Actually, I'll stick a link to that repair up there. I marked this board previously as serial and parallel OK. That's the first weird thing with this, that these 2 chips were fine. you know, in terms of the serial and parallel ports and diagnostics. The only point we became aware of an issue was when, you know, like I said, connected this up to the 590 and we booted from the floppy drive. Now at that point, when it was trying to read from the drive, this LED was not illuminating here. This was a clue to me. The other thing I noticed is the filter, as mentioned, wasn't working. So I started thinking, okay, what's the commonality between this LED here and the filter? And I'm not sure there is one other than the CIA here, and I think one of the LED signals goes here. I'm not sure about I think it's the filter actually. The filter signal goes here, but not the floppy LED. So I was puzzled as to why, when the floppy drive tried to boot when the 590 was connected, why was the floppy LED not illuminating? So it's like the short was occurring at the point it was trying to read from the floppy drive. And I'm speculating here that the 12 volts on the floppy drive, the fact that the motors and things were going, was the issue. That was kind of influencing a fault that was kind of, I don't know, something not switching there, was suddenly deciding it wanted to switch and short out. That's what I'm thinking was happening. I could be wrong, but what is really weird is if you remove the 590, the floppy drive was fine. The LED was fine. Now the filter still wasn't right. That was one thing I did notice. So it's very strange. But without a doubt, the strangest thing is, why was it burning out the RAM here? And it wasn't just getting lukewarm, it was getting absolutely red hot. Like a direct short had occurred in the RAM, and it wasn't just one chip, it was all four. So I'm guessing that we had 12 volts being fed into the 5 volt rail. We had an over voltage situation going on. Now there was a short occurring somewhere which was maybe limiting the current, because had we not had that, I think most of the chips on both of these boards would have been fried. The fact that this is running off the ATX power supply means it's got more current that it can draw. I'm not sure the rails are joined up though. I'm not sure like the 12 from here is joined to the 12 over there, or the 5 is joined to the 5, because at the very start of this video here, we had no power to this board, and that was when I realised obviously I hadn't got the thing you know, powered with its own power supply. So it's a little bit strange to say the least. Is there another fault still on the A590 that is only influenced when we had the issue with the Rev 6? I don't think so, because this A590 has been used an awful lot on that Rev 5 board. I mean, for like several hours non-stop without any issues. It's been disconnected, reconnected, disconnected, reconnected, and I tried it on a few other A500 boards and things, no issues at all. So I don't know, if you've got any theories, please post in the comments down below. I'll show you the pinouts of the 1488 in a minute, because somebody kindly on EAB, I just checked in the last half hour, has posted his theory, and that might be something to do with it. And it ties in with what I was saying about an hour ago now, that the 1488 down here, the supply pin on one of the corners there, it goes through a diode, I think, or there's some reverse polarity protection or something, or over voltage protection. It might be like you know, a clamping protection. There's a diode there that goes between the supply rail and pin 3, and if that diode was shorted, you'd have a problem. Now, having just read that on that forum, I've just measured the 1488 and there isn't a short. So pin 3 here. So pin 3, nothing. Short to pin 1, which I got short. So it's not short to pin 1. I think the ground is down here. So let's try that. Again, it's not shorted. So I don't know. It's not that. I might just have a look at the pin out of the 1499 in case this is an issue. So testing these two RAM chips here for shorts, I've seen no shorts at all. One of them was the original one, which was the proper, you know, the original fault on the 590. So that kind of gives me some confidence. It's not like the supply rail's shorted out and there's some pre-existing condition with the A590. I don't think there is. It's all been about on the second half of this video here, the 1488 actually. So the other chip, I might just retest it, because I did find that when it gets that, you know, that problem where the chips superheat up, it will, you know, even when you let it cool down for a minute or two, it will say the RAM's faulty, and you leave it to cool down for a few minutes until it's stone cold, and then it's okay. So it didn't actually kill any more chips. The number of times I actually tested while those chips were getting super hot. So testing on the A500 Plus here, this is one I repaired in a previous video. I'll stick a link up there for it. You can see I've got the BooBip switchable kickstart ROM in here. I had some interesting issues with that. I'd left the jumper on the position that enables compatibility with the earlier boards like the Rev 3 and the Rev 5, I think. So yeah, it took me ages to work that out, and as you can see, it's working. I'll show you this just booted to the desktop in a minute, but we booted from the Scuzzy here without an issue. Got 2 meg of fast RAM on the Zorro 2 and 2 meg of chip RAM on this board, because I've got an extra 1 meg in there, which is another video. As you can see, booty, and it's an A500 Plus here. So it was a good file test for this A500 Plus. I've tested the serial and parallel ports off camera. That was one thing I didn't do in the original repair. Serial and parallel ports were okay. The expansion RAM, as you saw, has worked. So actually, if I just click there, you can see you've got 2 meg of chip at the top there. So the additional 1 meg in the expansion bay there has worked okay. And we've got 2 meg of the RAM, and these are all the drives that I've got on my Scuzzy card there. So whilst there is definitely an issue with that Rev 6 board, there's also something on here, and this may have contributed to the issue on the Rev 6 board. It's driven me nuts, this. One thing I just did is I swapped over the kickstart ROM on the A500 motherboard there, and it wasn't in properly, so it's not like any of the pins were shorting or anything like that. It just wasn't a very good fit. I was using like a switchable ROM, and one of the pins wasn't making a good connection, which meant that it wasn't booting. Now, the net result is these chips start getting super hot again, just because the A500 couldn't boot. And I found that very unusual, to say the least, actually. And after having reseated the ROM chip and stuff, and letting the chips here cool down, connecting all back up, it was fine. But again, it's bothered me. I'm like, what is going on with this? Why are these chips almost setting on fire when something is occurring somewhere? So I started thinking about capacitors. Now I had a measure around on every single cap on here. There is quite a low resistance, like I don't know, 20 ohms or something across the VCC rail, but compared to the A590, and that's almost identical, so I don't think that's the issue. But considering we're getting an issue, I was trying to contemplate or think, theorise what might be going on. And I think what might be happening is maybe the 12 volts is shorting to the ground, raising the 12 volts. I don't even know that that's possible, because if you got a short, you'd think there wouldn't be an issue. But what I'm trying to think is, if the ground was short to the 12 volts and the ATX power supply is providing a ridiculous amount of current, maybe the 5 volt level is then going to like -9 or something. That might be why these go super hot. Maybe only these go super hot because these are the ones that are nearest the supply. That would kind of explain it, because which means that the issue is perhaps in this area of the board. Because if it was something down here, I would maybe expect some chips nearer. And I do think that's what's happening. I think these chips shorting out are stopping everything else from burning up. Does that make sense? And we might just be lucky that there's 4 here in parallel. If you just had 1 on here, it might just obliterate that chip, and then it might obliterate something else, etc. I don't know. Or having said that, if it shorts, then it'll save other things. When you get short, it can save other things on the board. I've seen it before where RAM chips short, and it saves the rest of the system. So I went around with the ESR meter here. I'll just show you. We've got one there on the 5 volt rail, just to test that. It's really low, 0.8. I mean, it's saying in circuit leaky. It is in circuit, and you'll get that leaky thing when it's in circuit. So that looks alright, and that's on the 5 volt rail anyway. But the one down here is on the 12 volt rail, and let me just show you this. I think this cap might be the issue. We'll take this off and measure it, but I think that might be the issue. 1 ohm. That is a resistor. So it kind of could explain it, that maybe there's an issue here and we're getting a short between 12 volts and ground, and something to do with having a power supply here and a power supply on the A500, and the ground's been different, although they're probably commonly joined, I would think. Something's going on, and I think it's shifting the 5 volt level. That's what I think's happening, and I think these are saving the board. Now, when this happened a minute ago, luckily none of them failed. You can see I pulled them all out here. None of them failed. It's still working, but I do need to get to the bottom of this. Anyway, let's remove that cap and just measure it out of circuit. So I've lifted one side up out of circuit, and you can see It is indeed a resistor. Look at that, 1.16. This is as it's cooled down, 1.17. So I think that's the issue. I think that is causing me a problem. It's going up. So I've got a brand new Panasonic FR series here, and you can see that's a lot lower. It's higher voltage as well, 50 volts, but that's why it's slightly higher here, but it's certainly not the over 1.2 ohms we're seeing. So yeah, I'm going to swap that one out. So replace that cap. I could have used some heat shrink on the legs there, but they're not touching the board, there's nothing for them to short on there, that'll be fine. But the other thing I'm going to do is just clean here. Can you see? Look how dirty it is inside the gaps there, and around the dip switches and stuff as well. I'm not sure you're going to be able to see that, but it's like, I don't know, dust and stuff. So I'll just get some IPA onto a toothbrush here and just have a bit of a scrub around here, and then mop up with some cotton buds. So the crazy thing is, this video was turned into a Rev 6 A500 repair rather than the A590. I spent a lot of time trying to understand what is going on here. Just once or twice yesterday I got the issue where the chips on the RAM on the A590 start getting red hot again. So looking at the MC1488 datasheet here, you can see we've got an awful lot of diodes around the place here. So you can see there just about pins 6, 8, 11 or 3. You've got a resistor to the output, but then you've got this diode here, a diode here. So it's like, this is the thing, and this is what the guy on the EAB I think was trying to suggest, that maybe one of these was short, because there are diodes all over the blooming place on here. But as you just saw, I measured and I found no shorts. So I think we can kind of rule the 1488 out, actually. Having said that, the filter was not working, so I don't know, maybe there was a problem on this Rev 6 A500 as well as the A590. But I also found it interesting that the RAM that burnt up is the same RAM that failed when this first arrived to me, actually. So maybe it's a common problem on Amigas where you get a problem with the filter, and for one reason or another that I still haven't worked out, maybe that kills that RAM on the A590. Or maybe it's to do with the power supply I'm using, because I've got an ATX power supply on there. Your grounds, your grounds could be different. If you've got like a linear power supply on one, mind you, it's not linear, is it? The A500 power supply I'm using is a switch mode. But still, if your grounds, maybe if you've got a bad ground, a difference in ground levels could mess things up as well. The supply rails are not connected, are they? So like our 5 volts are not connected with each other. So if your ground levels are differing, let's say you had a dirty ground, a bad ground, your ground levels could be offset, which means your voltage levels are offset. Maybe if they're floating over a period of time you could get a problem, but then why would it only be prevalent when you connect the floppy drive up? Because this is the thing, this is what started this whole mystery thing off, is when I connected the floppy drive up, the floppy drive was not behaving normally. It was like start to boot, it would be reading the boot sector, struggling, the floppy LED would not be working, and then occasionally when that was happening I'd notice suddenly the system would stop responding and those RAM chips would start getting red hot, and yeah, it just doesn't make any sense to me. So sorry about the glare on the screen here, but you can see here this is the underscore LED signal for the filter, and you can see it goes into pin 2 of the 1488 and pin 3. This is where I measured, just measuring between ground and on volts DC on the multimeter, pin 3 there, bang, it dies instantly. Now I did open this up to discussion on Twitter, no one had any ideas. I even tried to get Dave Jones from EEV blog involved, because it's the sort of thing where he may look at the data sheet for the 1488 and look at how this is wired and go, ah yeah, I can see what's going on here. Is it something to do with this being like a high gain device, or I don't know, I could be talking rubbish here. I'm thinking that maybe there's a slight change in impedance here would cause some sort of overdrive situation. Is that what happened? I don't know. And I think ultimately this pin here is where this LED signal comes from, the CAA that died. Yeah, that's the other mysterious thing, is if measuring here killed the output on this 1488, why did it seem to backfeed and kill the CAA? There seems to be some sort of, inside that 1488, you just saw the schematics earlier, there must be some sort of failure mode there whereby the output failing back feeds to the inputs. I don't know. It's just really weird. So a quick look at the schematics here. So the first point of interest is the power connector here. The interesting thing with this, it's got a power sense pin, and I'm not sure which way around this works. I would assume that the original power supply that went with this would be detecting 5 volts as an input here, and then power the other rails. Does that make sense? So that when you've got this connected up to an A500, it can detect that the A500 is powered, and therefore power this at the same time. It's like a soft power on for the power supply that should be used with this. So would that cause the problem? I don't think so, because I'll be honest, in every instance I've tested here, the first thing I've done is power on the A590 first, so that's sat there powered. And that power sense pin comes from the A500 edge connector. You know, this is the connector on this diagram here, but that connects to the A500 edge connector, and the power sense is there. So could that be related? I don't think so. I don't think so, just based on the fact that the grounds are joined up. And that's the key thing here as well. It would be super critical to make sure that the ground is a really good connection between the A590 and the A500. Because if those grounds are not joined, you can have floating levels. You can have different levels. You know, the 5 volts on one board versus the 5 volts on the other could be different. And it's the same with the 12 volt. So again, could that be the issue? Could we have had a bad ground there? I don't know. The A590 itself, as you'll see in a minute, it looks fantastically clean, the connector and stuff there, so strange. And we'll look at some of the other things as well. We've got the Dmac chip here. It's almost identical to the A2091. The 2 bus transceivers here, 245s. You've got the odd bit of logic, you know, standard logic like 74LS32. You've got your boot ROMs here. Again, as I said, the ROMs are the same as the A2091. Some stuff down here for clocks or something. You can see there's a 7 MHz clock as output there from 74 series stuff. There's the PAL I mentioned earlier on, or a GAL. It's a 16R4, it says there. And there's the jumper to decide whether this chip is used or not. It says if that chip is fitted. So it looks like you could literally enable or disable that chip, you know, remove it. I'm not sure why you would do that, I don't know. XT IDE connectors there, the same Scuzzy control chip WD33C93. So the same thing holds true that I pointed out in the A2091 video, that if you want to run at 14 MHz, you can probably do that on here, but you would want to uprate this chip probably. And there's the other PAL down there. And you might not be able to see from there, but you get the DTAC, underscore DTAC signal out, RAS, CAS, MUX, A17 MUX, so all stuff to do with the RAS and CAS and timing of RAM and stuff there. And then finally, the page with all the RAM chips here, and these are just supplied by, you know, the VCC 5 volts and a ground. There's nothing special about these. What I don't get is why those 4 in that area of the board were getting super hot. The only thing I can think is because of their proximity, as I say, to the power connector, which would suggest the whole issue I've been having here is about voltage levels. Maybe something's got shifted somewhere because of having 2 separate power rails, maybe from having a bad ground. So would you believe it, I thought I'd solved it and I haven't solved it. I've just come to test it again towards the end of this video, and the same thing has just happened, exactly the same thing. Connect floppy drive up, starts getting hot, you know, the RAM chips, and yeah, switch it all off really quick. Everything's alright, nothing's died, the CIA's alright, the filter's alright. The filter was a separate issue on this board. We resolved it as part of doing all the stuff we've done here. Anyway, I'm going to join the connections up on the underside of the A590 here, just 2 of them, 5 volts and 12 volts, directly to under here, and I'm going to stick a label on there, do not use. That's what I'm going to do, because I strongly believe the issue here is about differences between power supply levels, maybe the ground, I don't know, because the ground is always joined. This is the mystery, but I do think it's something to do with that, actually. So if we test from one of the VCC pins of a 74373 over there, that's measuring as a low resistance. It's not, though, it's not short. That is a short. So you've got 1, 2, 3, third one on the top there. So as we put this here, it's going to be the top row here, the 3rd pin along. So I just need to solder 5 volt wire from there to up here. I need to work out where 5 volts comes in on here again. And I'll do the same thing for the 12 volts, and we'll give it a final test there. So I've soldered my red wire on. I just need to work out where to feed it to here on the DIN. So I know that this pin here is VCC. I've just checked that to one of the 7.4 series chips on this board. We've got resistance there. It's not a short. However, that is a dead short, 0.001 or 0.01. So we're going to solder it there. So my red wire is just going to come up here like that. You can always just secure this in places with a little bit of hot glue, not over soldered connections. So measuring from the left hand pin on the underside here of the floppy power connector, that's plus 12, that thick rail that comes all the way across here. Then on connectivity test, so we got 1, 2, 3, 4, 5, it's there, fifth one, dead short, 0 ohms. So yeah, let's just check that, 1, 2, 3, 4, 5, yeah, fifth one on the underside there is 12 volts. So I'll redo this later because you can see the orange wire I've used for the plus 12 here. It's slightly thicker gauge. I'd like to go with the same gauge of wire. It doesn't look great. And then later, as a off camera, I'll secure these down with a little bit of hot glue strategically in a few places. Like that mod there, can you see that? It's like a factory mod. I'll do the same thing. I might even get a yellow wire for this instead of an orange wire. Anyway, so you can see 1, 2, 3, 4, 5. 1, 2, 3, 4. Fifth one up. Fifth one up on the outer edge here. That's plus 12. And the third one up on the inner edge here is your plus 5, and those are just going to the corresponding points here for the plus 5 and the plus 12. I'm just going to double check that plus 12 one in a minute. I know the plus 5 one's definitely right. I want to just check that, make sure that's okay. So I do believe that is the final piece of the problem, and that has been the problem all along with the A590. Now the person I bought this A590 from told me they'd used a CD32 power supply and couldn't get it working. So I think it killed the RAM in a similar way that what happened here, because I'm suspecting and I could be wrong, but I'm suspecting that the CD32 power supply doesn't have that set power sense pin. So the whole thing about powering these on in the right order is majorly critical, and the fact I was using an ATX power supply to power the A590 on the left here, and an A500 power supply to power the A500, it was something to do with, you know, power on and power off cycles. If I left the A590 powered up but switched off the Amiga, connected up a floppy drive, then switched the Amiga back on, I think there was some sort of mismatch going on with voltage levels. I don't know how. It's probably because I don't know, there's some like beads or something in between the ground connections. So you've not got an absolute direct ground connection, and maybe the grounds were kind of floating away from each other a little bit on power cycles. I could be wrong. If you know more about what's going on there, please post in the comments down below. I'd be fascinated to understand that. But I am sure that's what's wrong. Now, you may think maybe the power supply I was using has got a problem. It hasn't. It's been recapped, and I very cautiously measured the voltages a number of times whilst these issues are going on. And the power supply is rock solid. There's nothing wrong with the power supply. So I do think the issue with the 590 and what probably killed the original RAM chip, what killed the RAM chip, you know, when I experienced the problem where the chips were getting super hot, was all about power supplies. Actually, you've got to use the right power supply for this. You may be wondering, why did they not just wire this in like I have now to pull the power from the A500? Well, it's all about current, you know, and power capability. The power supply you're using, if you're going to do something like this, you need the beefier one. One of the original power supplies, they don't deliver as much current on the 5-volt rail. It's something like a few amps less, actually. So you do need the beefier power supply. But the other issue here is the 12-volt rail. If you were to try and power a proper hard disk, one of the original, you know, Scuzzy drives in here, the amount of current that's going to draw on the 12-volt rail, I don't think the A500 is going to be able to provide it. It may do. It may do. You can post your comments down below if you've tried it. It may work, but it's going to be putting undue stress on the 12-volt rail there. And of course, we're putting a bit of additional stress, quite a lot of additional stress, with all the chips that are there now being powered by the 5 volts of the A500 power supply. But anyway, I am very pleased that I finally got there in the end. We inadvertently discovered the problem with the LED on the you know, the filter on this Rev 6 A500. So it was a separate thing. So I guess you could say this video is two different faults here. The whole issue measuring the CIA, that is unexplained. Still don't understand what's going on with that. That is a separate issue. If anybody's got any insight into what's going on there, please let me know. But what I do know, as I mentioned in the annotations, a friend of mine, Liv2, one of the Patreon guys, I forget his first name, I'll perhaps post it down in the comments below later, but he kindly went away and measured his. I said, look, please don't do it, it might blow your CA. He's like, oh, well, I'm curious, I've got to test this kind of thing, I've got to see what's going on. And he measured it on his and it killed his CIA as well. So please do not measure pin 2 or pin 3 on the MC1480A, because you will kill your CIA. Maybe if you use a really super high impedance scope or something, you'll be alright. Maybe a scope would measure it okay, and it's something to do with the multimeter. So just wrapping up here now, yeah, we upgraded the ROMs to V7, that's a must if you get one of these. And you can see it's Party Mix, the actual name for the board there, it's code name. And just like other Commodore products, you can see the people that worked on it there, Boyer, Augie, Beats, what's that say there, 9SPCB, Westchester, USA, I think. Copyright 1989. So yeah, a very nice board here. I'm glad we've got this up and running. I'm glad we didn't destroy it with the overvoltage, or I think it was overvoltage. You may think it was just about something short in somewhere. I don't think so. These were so hot, I reckon you could probably put a piece of solder on there and I think it would melt. You know, I showed you the bit where I had that white stuff on my finger. It burnt me really badly. It took about a week to heal. Actually, it was a really bad burn just from going like that just for a second. Ah, my god, you know, it's like the pain was incredible, and my skin all blistered and everything. It was horrendous. But I can't help but wonder if this is what kills these when you use a genuine power supply. If you've got a problem with the power supply and that sense pin is not making a good connection or something like that, you could get the same issue whereby this voltage issue kills the RAM here. And as I say, I think it kills the RAM here, and this RAM gets hot. None of this does here, just this here gets hot. And I think it's probably the close proximity to the power connector on the back there. You can't quite see, you know, the power DIN there. That's just my theory anyway. And the reason I chose to connect these wires here instead of here, and in fact the 5V rail, you could literally pull it over to one of the 7.4 series, you know, there'd be a VCC pin around here, you could have a really short wire for that 5V. But what I wanted to try and do is retain the characteristics of, based on the issue we saw, that should the problem reoccur, yeah, let's say I've not solved it and there is an issue somewhere, then the nature of the fact that it's powered from the same point up here should mean, in theory, if that voltage issue became a problem, these would overheat again, rather than something down here, because this is the problem. You connect 5V up from, you know, the edge connector here to somewhere over here. If you had a problem like we've experienced in this video, stuff around here could die. Well, you don't want your PAL dying, you don't want your Dmac dying. And that's the only theory I can come up with as to why these get super hot. Because if it was just about a data signal somewhere being incorrect, it wouldn't be these here, it would be random and stuff as well. So another problem I ran into, trying to get hold of an MC1488 there was proving difficult, and I ended up getting a substitute. On eBay it was described as, you know, I think it was an ST part actually, and the person selling it said this works fine as an equivalent for the 1488. And I fitted it, and yes, it works, but one thing I found is that when you switch the filter, toggle the filter, as I'm about to show you in a minute, it started to get super hot. Now it continued to work, and you could use it for hours on end, but whenever the filter was, I think it was when it was on, it got super hot. So that was bothering me for ages as well. Eventually I got some brand new old stock MC1488s, stuck one in, no problems, no temperature issues. So just bear that in mind. If you see the SN part as an equivalent, don't go near it. Not on this board, maybe on other systems will be okay. Now the keyboard I'm using with this, it's one of the older revs, I think. That's why you got a red power LED there. And if I switch the filter off and on, did you see it change there? It goes dim, look. When the filter is off, filter's on, it goes brighter. So yeah, the LED is behaving normally once we change that 1488, and the filter is audibly going off and on. Hopefully that'll get picked up on the camera. Sorry if I've annoyed your ears. So as you saw, that A500 is fixed as well, so you got 2 repairs here for the price of 1. Anyway, I'm very pleased with it. It's a fantastic little addition to my collection. Just means I can now plug this into any A500, you know, including the A500 Plus, and boot a load of games from hard disk, and of the extra 2 meg of RAM as well. So yeah, hopefully you found the video interesting. Thank you very much to my subscribers and my Patreons. If you would like to support the channel, keep the channel going, you know, it funds pickups and things like this, really. I've spent a crazy amount of time on this. I spend a crazy amount of time on these videos in general. So thanks a lot. I'll catch you in the next video.